Hello dear students, I am Rana Kumar, your physics faculty at Aakash, and a very warm welcome into this session in which we are going to discuss the selective problems for the paper AIATS plus 2025 phase 2 mock test 3 that was conducted on 2nd of February 2025. And I will be taking the discussions, the problems based on these chapters: current electricity, motion in straight line, kinetic theory, thermodynamics, alternating current, and electromagnetic waves, right? Important chapters from the point of view of NEET examinations. So let's dive in and let's move towards our first problem. It says that, and it was problem 1 for the original paper. It says that for a moving particle, which of the following is true? So basically, you need to pick the correct statement, right? So the keyword over here is true. So you need to pick the statement which is correct. Now let me go through the statement. It says that magnitude of average velocity may be greater than the magnitude of average speed. Second one says that average speed may be greater than the magnitude of average velocity. Third one says if magnitude of average velocity is 0, then average speed Hello dear students, so very sorry for the technical glitch. Let's continue with the class again. And let me read the problem again for you. It says that for a moving particle, which of the following is true? And we are discussing the first question, so you haven't missed anything. And the option says that the magnitude of average velocity may be greater than the average speed. The second one says that average speed may be greater than the magnitude of average velocity. Third one says that if magnitude of average velocity is 0, then average speed must be 0. And fourth one says that average speed is always greater than average velocity. So dear students, this problem is more or less based upon the concept of average velocity and average speed. So before dealing with the problem, you must be very clear. About what is average velocity and what is average speed. Now, if I try to define the average velocity, V average, and this is average velocity, so it will be total displacement upon total time taken to cover this displacement, right? So this is the basic standard definition of average velocity. How do you define average speed? So V prime, let me denote as V prime. So V average in this case will be defined as total distance upon total time taken. I hope you know these basic formulas for the average velocity and the average speed. Now you need to compare the average velocity as well as the average speed. So average velocity depends upon the displacement and the average speed, it depends upon the distance. And we all know that magnitude of displacement, the magnitude of the displacement, it is always less than or equal to distance. Right? So distance covered by a body, it may be equal to the distance covered by a body, or it should be less than the distance covered by the body. The displacement of a body cannot be greater than the distance covered by the body. That is the basic fundamental that you need to keep in mind when you are being asked to compare the average velocity or the average speed, right? So mode of displacement is less than distance. That is a basic fundamental, right? Now let's head back to the options. So first one says that magnitude of average velocity may be greater than average speed. So it tries to say you that if average velocity is greater than average speed, it means that the displacement covered by a body may be greater than the distance covered by the body, which is obviously not true. So this option should be wrong because mode of displacement is less than or equal to distance, right? So first option is cleared, it is a wrong one. Let's talk about the second one. It says that average speed may be greater than the magnitude of average velocity. So this one is right because average speed, it depends upon the distance covered by the body, and average velocity depends upon the displacement covered by the body. So if average speed may be greater, why may? Because there are cases in which the distance covered by the body will be equal to the displacement by the body. So in that case, average speed may be equal to the average velocity. So that's why there is a may. Had there been the statement as average speed is always greater than the magnitude of average velocity, then that would be wrong because it cannot be always greater. There is a equality condition also. मतलब ये है कि average velocity or average speed, they can be equal also. And for the general cases, average velocity will be the average velocity will be greater than the average speed will be greater than the average velocity, right? So this one seems correct. Let's talk about the third one. It says that if magnitude of average velocity is 0, it means that the displacement of the body is 0, then average speed must be 0. Now it says that if displacement by the body is 0, then the distance covered will also be 0. Like if I take this case, if a body starts from here, right? Body goes on till this point, turns back and returns to its initial position. So this is initial position and this is final position. Now for this case, you can very well say that the distance covered by the body is non-zero. However, the displacement of the body is zero in this case. So average velocity for this case is zero, but average speed is non-zero. So my option was saying me that magnitude of average velocity is zero, then average speed must be zero. This is a wrong statement again. Let's talk about the fourth one. It says that average speed is always greater than average velocity. Now, it says that average speed is always greater than average velocity. This is wrong, because average speed can also be equal to the average velocity. Consider this case. If a body starts from here and it goes all the way till here, from O to A. Now for this case, for O to A, the distance covered by the body is equal to the displacement covered by the body. So in this case, for this case, I can write that V average, if this is velocity, it is equal to, and if it should be equal to V average speed. So not always. The always word was a problem over here. This always word was a problem over here. So it is not always true. They may be equal also. So this one is also wrong. So the correct answer to this problem is option 2. And I hope you are clear with this concept. And a very good afternoon to everyone. Right. Now let's move forward to the next problem, and it is a problem based on the chapter of Kinetic Theory of Gases, and a very standard problem from this chapter you can expect to be from RMS velocity. So you need to know the standard expression for the RMS velocity, and we very well know that VRMS it is equal to under the root of 3RT by M, right? 3RT by M. What is R? R is your universal gas constant, M is your molar mass, and what is T? Very important, T is your temperature in Kelvin. The important point over here is that you need to put the temperature in Kelvin while using this expression. So the basic fundamental is this expression VRMS, it is equal to under the root of 3RT by M. R is your universal gas constant, M is the molar mass, and T is your temperature, and that too in Kelvin. Now the temperature of a gas, it is increased from 127 degrees Celsius to 527 degrees Celsius. The RMS speed of gas molecules will increase to a factor of. So it should increase to a factor of what they are asking you. Now initial temperature is 127 degree Celsius. So you convert it into Kelvin. So you add 273 plus 127, right? So 27 degrees Celsius is 300 Kelvin. So 127 degrees Celsius should be 400 Kelvin. So it will come out to be equal to 400 Kelvin. And going by the similar logic, 27 degrees Celsius is 300 Kelvin. 27 degrees Celsius is 300 Kelvin. So 527 should be 500 plus 3, that is 800 Kelvin. So final temperature is 800 Kelvin. Right. Now, if I try to compare that, let me assume that V1 is the RMS velocity corresponding to 400 Kelvin, and V2 is the RMS velocity corresponding to 800 Kelvin. Right. So the gas is same. R is a universal gas constant, so it is going to remain constant. The gas is same, so the molar mass is also going to remain same. So the only thing that is varying over here is temperature. So I can write that V1 by V2, it should be equal to under the root of T1 by T2, that is 400 by 800. So I can write that V1 by V2, it should be equal to 4 by 2, that is 1 over root 2. So V2 is coming out to be equal to root 2 times of V1. V2 is coming out to be equal to root 2 times of V1. That is, the RMS speed of gas molecules will be increased by a factor of root 2. That means that the correct answer to this problem is option 3. So this one is wrong, this one is wrong, and this one is also wrong. And these are the kind of problem that you can expect in the actual NEET examinations. This RMS speed expression, you must be very thorough with this expression, because many problems are asked based upon this expression, right? And yes, some people have commented about the what is R. So yes, R is a universal gas constant. Now let's move forward to the next problem of this session. And again, the problem is based on the chapter of thermodynamics. And it says that it was problem 8 of the actual paper. It says that heat Q joule, okay, the heat Q joule is transferred to ideal hydrogen gas in an isobaric process so that gas performs 4 joule of work. So heat Q is, so you need to find heat Q. The process is isobaric and you are supplying some heat Q to the system and the system is performing 4 joule of work. So what is happening is that, let me take this as my system, and it is going an isobaric process in which heat Q is being supplied and the system is doing 4 joule of work, right? So you need to find heat Q. Okay. Now dear students, if I try to write that for isobaric process, we very well know that pressure remains constant, right? Isobaric process, what is the meaning of isobaric process? The pressure is going to remain constant, which means that for isobaric process, if I write the delta Q, that is heat interaction of the system, it will be equal to NCP delta T, right? N is the number of moles, Cp is the specific heat at constant pressure, and delta T is the change in temperature. What about delta U? Delta U, a very standard expression we have, it is equal to NCV delta T, right? So delta U is NCV delta T. And what about R? Sorry, not R, but W. What is delta W? The work interaction. It is equal to, from the first law of thermodynamics, delta Q minus delta U. So it should be equal to NCP delta T minus NCV delta T, right? So N delta T, if I take as common, it will be Cp minus Cv, which gets to NR delta T, right? So this is the work interaction of the system, NR delta T, right? Now let's go back to the problem. Our problem says that 4 joule of work is done by the system. So I can write that NR delta T is equal to 4. I'm not taking this sign because obviously work done on the system will be taken as negative. Okay, so this convention is a little bit wrong. Let me make it again. So the convention says that the work is being done on the system and heat is being released by, work is done on the system, heat is being, okay, not, okay, the first one was right. Let me draw it again. So heat is transferred to the system and the work is done by the system, right? So according to the problem, NR delta T is given to me as 4, right? So I can write that N delta T, the value of N delta T, it is equal to 4 over R. This is my equation 1. Now I need to find the value of delta Q. Based upon our discussion, the value of delta Q, it is equal to NCP delta T. So I know that the value of N delta T, it is equal to 4 over R. So I'll put it over here. So 4 over R into Cp. What is the value of Cp? For finding out the value of Cp, you have been given that it is a hydrogen gas. Hydrogen being a diatomic gas, it will have 5 degree of freedom, I guess, 5 degree of freedom. So Cv will be 5R by 2 and Cp will be 5R by 2 plus R, right? Cp you need to find, it will be equal to Cv plus R. Being a diatomic, it will be 5R by 2 plus R, that is equal to 7R by 2. So Cp for hydrogen gas is coming out to be equal to 7R by 2. That's it. You need to put the value of Cp as 7R by 2. So let me cancel this R and R. It is coming out to be equal to 14 joule. So 14 joule, that means that the correct answer to this problem should be option 3, that is 14 joule. So this one is wrong, this one is wrong, and this one is also wrong. And if delta Q is 14 joule, what should be delta U? Can anyone comment the answer? What should be delta? What should be delta U? So the system was something like this. Delta Q was supplied to the system. Work was being done by the system. So delta Q is 14 joule. W is 4 joule. So what is delta U? It should be equal to 10 joule. Delta U should be equal to 14 minus 4, that is equal to 10 joule. And you can also find delta U even if you don't know what is delta Q, because delta U, it is equal to N CV delta T, right? So value of N delta T was 4 by R, and the value of CV for hydrogen gas, it will be 5 R by 2. So let me cancel this R and R. So it is coming out to be equal to 10 joule. So either way you approach the problem, either you go by the first law of thermodynamics or either you go by the formula, you will reach the same point, right? So that's how you calculate the delta Q and the delta U for such kind of problems. This problem was based on the process, isobaric process. So you need to remember these formulas for delta Q, delta U and delta W. These formulas will come handy while dealing with the problems of isobaric process, right? So I hope I made it clear how to deal with such problems. Now let's move forward to the next problem. Again, it is a problem based on the chapter of current electricity, and it is based on the combination of batteries, right? Let me go through the problem. It says that two batteries of EMF 4 volt and 2 volt of internal resistance 2 ohm and 2 ohm. So both the batteries, they are having internal resistance to be equal to 2 ohm and 2 ohm, are connected as shown in the figure. The effective potential difference of the combination across AB. So you need to find the effective potential difference of combination across AB, right? So dear students, first of all, to solve this problem, you should know the concept of terminal potential difference across the battery. See, E denotes the EMF of the battery and R denotes the internal resistance of the battery. Now what should be the terminal potential difference across the battery? That is, what should be the potential difference across this point A and B, or what should be the terminal potential difference when the battery is charging? So battery is charging, it means that current should be flowing in this direction, right? In this case, the terminal potential difference, or delta V, it is equal to E minus, not charging, it is discharging. So this is the case of discharging of battery. Here battery is supplying current, so battery is discharging. In that case, delta V, terminal potential difference, it is equal to E minus IR if the current I is flowing through the battery. And there is one more case possible, B, A. Suppose that the battery is charging. In the second case, the battery is charging, so delta V, it should be equal to E, this is E and this is R. So it will be equal to E plus IR. One is the case of discharging, one is the case of charging, and you must be very clear that where the current goes while charging and while discharging. So these are the expression for the terminal potential difference, and if no current is flowing, in that case the terminal potential difference will be equal to the EMF of the battery, right? Now let us solve this problem using the concept that we just discussed. If I assume that the current I is flowing like this, right? So let us apply the Kirchhoff law in the loop. So I'll go in this sense. It says that there is a drop of 2 volt. So say there is a drop of 2 volt. Again there is a drop of IR. So 2 into I. Again if you go this side, there is a drop of 2 into I. And after that there is a gain of 4 volt. So minus 4, it should be equal to 0 as you move across the loop. So it should be equal to 2 plus 4I minus 4 should be equal to 0. So it should be equal to 4I is coming out to be equal to 2. So I is coming out to be equal to 1 over 2 ampere. Current is coming out to be equal to 1 over 2 ampere. Sir, आप हिंदी में भी बोलो. Okay, I'll try to speak. So if you talk about this battery, if the current is flowing in this direction, this battery is discharging, and for the case of discharging, we just discussed that the terminal potential difference, it is equal to E minus IR, right? So it is equal to E minus I into R. So you need to calculate the potential difference across this point A and B, A and B. So it should be equal to the terminal potential difference across this battery, and it is discharging, so it should be equal to E minus IR. So value of E is 4 minus current is 1 by 2 into R is 2. So 4 minus 1, it should be equal to 3 volt. And you can calculate the same thing from the this battery also. This battery over here, it is charging. So terminal potential difference should be equal to, yes, it should be equal to E plus IR. Put the value of E. E is 2. So 2 plus I is 1 by 2 into R, that is 2. So it should be equal to 2 plus 1, that is equal to 3 volt. Right? So 2 plus 1, that is equal to 3 volt. So correct answer to this problem should be option 2, that is 3 volt. Either way, you solve for this or you solve for this, right? You can also solve this problem with the help of equivalent EMF. Suppose that we have a battery like this. This is E1, internal resistance is R1, and you have a battery like this. This is E2, and you have an internal resistance R2, right? And suppose that it is supplying current I1 and it is supplying current I2. So current over here, I, it is equal to I1 plus I2. Current over here is equal to I1 plus I2. So we know that both the batteries, this time they are discharging. So terminal potential difference V, it should be equal to E minus IR. So using this equation for this battery, I can write that I1, it is equal to I1, it will be equal to, I1 will be equal to E1 minus V by R1. Right? And what about this battery? It is also discharging. So from here, I2 can be written as E2 minus V by R2. Right? And if a equivalent battery is assumed, this is my equivalent battery. So this is E equivalent and this is R equivalent. So I can write that from this current I flows. So I current can be written as E equivalent minus V by R equivalent. Right? So I is equal to I1 plus I2. So you can write that E equivalent minus V by R equivalent, it is equal to E1 minus V by R1 plus E2 minus V by R2. Let us simplify the expression. So it will be equal to E equivalent by R equivalent minus V over R equivalent. It should be equal to, if I rearrange this, it should be equal to E1 by R1 plus E2 by R2 minus V I take as common, so it will be equal to 1 over R1 plus 1 over R2. So this is the formula for the equivalent resistance, equivalent internal resistance, and this is the formula for equivalent EMF. Right? So if you try to apply this formula in this problem, so you can apply, okay, I'll erase this. Let us solve with the help of this formula also. So equivalent EMF, we just derived the formula, is equal to E1 by R1 plus E2 by R2. So E1 is 4 by 2 plus 2 by 2. That is equal to 2 plus 1, that is equal to 3 volt. Right? So that's how you can solve the problems of combination of batteries. Either you go by the standard approach, you can just use the Kirchhoff law, or you can use the concept of equivalent EMF and equivalent internal resistance. Either way, you should remember the formula and you are good to go with such kind of problems, right? Now let's move forward to the next problem, and it is problem 20 of the original paper. It says that which of the following statements is correct about the electromagnetic wave? So the problem is based on the chapter of electromagnetic waves. let me go through the problem. It says, let me go through the options. It says that both electric and magnetic field vectors are in opposite phase. Now, dear students, it has been asked, it has been discussed numerous times that the electric field as well as the magnetic field that are associated with an electromagnetic wave, they are in the same phase. Both will attain the maxima as well as minima at the same time. However, the direction of propagation, both of them are perpendicular to each other as well as they are perpendicular to the direction of propagation also. So there should not be any confusion regarding the phase between the electric field and the magnetic field associated with an electromagnetic wave. It has been discussed several times that the phase difference between the electric field and the magnetic field associated with the electromagnetic wave is equal to 0. So it says that are in opposite phase. This one is wrong, right? Let's talk about the second one. It says that electromagnetic wave requires a medium for propagation. No, electromagnetic waves don't require any medium for propagation. They can travel in vacuum also, right? So this one is also wrong. EM waves are not mechanical waves, so obviously they don't require any medium for propagation. Let's talk about the third one. It says that energy in the electromagnetic wave is divided equally between the electric and magnetic field. Yes, this one is correct. Energy associated with the electric field, it is equal to, energy associated with the electric field, it is equal to half epsilon naught E naught square, and it is the energy associated with the magnetic field, it is equal to B naught square by 2 mu naught, and both of these are equal, B naught square by 2 mu naught. So yes, the energy is equally divided between the electric and magnetic field of an electromagnetic wave, right? So energy in the electromagnetic wave is divided equally between the electric and magnetic field. Yes, this one seems perfectly right. So the only correct answer among all these three statements is option 3, right? So option 3 should be the correct answer, and this one seems wrong. Option 4 that says both 2 and 3 are correct. Obviously this one seems wrong. So I hope I made this point clear to you, how to deal with the theoretical problems of electromagnetic waves. Now let's move forward to the next problem. Okay, and this is the problem based on the chapter of alternating current, and the problem says that a reading of voltmeter V shown in figure at resonance, keyword resonance, and it says that the reading of the voltmeter at resonance is 200 volt. 200 volt, then the quality factor of the circuit is what we are required to find. So you need to find the quality factor of the circuit. Okay. So to find out the quality factor of the circuit, first you should also know that what is quality factor. If anyone knows what is quality factor or what is the expression for the quality factor, you can put the answer or the formula in the comment box. Up till then, I'll try to explain to you what is the meaning of the quality factor. So this is the graph right in front of your screen. It is the graph which denotes current and the angular frequency associated with the series LCR circuit, right? So on y-axis there is current, and on the x-axis there is omega. Now at this frequency, this is resonant frequency omega r. At this frequency the current is maximum. Obviously at resonance frequency omega r, current is maximum, right? And the power dissipated is also maximum for this frequency. So omega r is your resonant frequency, and I hope you know the expression for the resonant frequency. There are two certain points that you need to take into consideration for understanding the concept of quality factor. So I have taken two other frequencies. This is my omega 1 and this is my omega 2, right? And let me write omega 1 as omega r minus delta omega, and omega 2 as omega r plus delta omega. Obviously omega r is your resonance frequency. Okay, someone is commenting me the answer. Okay, so omega r minus delta omega, omega 2 is omega r plus delta omega. Now what is the significance of these 2 points? These two frequencies are the frequencies at which the current is I max by root 2, or power dissipated is, so current at these 2 points is I max by root 2 at omega 1 and omega 2, right? Omega 1 और omega 2 दोनों पे current की value is I max by root 2, और रेजोनेंट फ्रीक्वेंसी पे करंट की वैल्यू है I max, right? Now quality factor Q. Quality factor is defined as the ratio of resonant frequency upon the bandwidth. Now what is bandwidth? Bandwidth is this distance. See, this one is omega r if I talk about omega 2. So bandwidth, it is defined as omega 2 minus omega 1. So if you subtract this, it will be equal to omega r plus delta omega minus omega r plus delta omega. So this omega r and omega r cancel. So bandwidth, it is equal to 2 delta omega, which is eventually equal to r over L. Right? So your quality factor is defined as the ratio of resonant frequency upon the bandwidth 2 delta omega. So quality factor, it becomes resonant frequency upon the bandwidth 2 delta omega. It was eventually equal to r over L. So put r over L over here, right? So this is the expression for the quality factor, right? I'll write the expression for you over here. Quality factor, it is equal to omega r over r by L. Now have a look at the problem. They are giving you the reading of the voltmeter across the capacitor. How to find the quality factor using these two, using this much data. You have been given 50 volt over here, 200 volt over here. That's it. That's it. That's the data given to you in the problem, and you need to figure out what should be the quality factor of the this LCR series circuit. How to find out? Because this doesn't seem to fit the formula that we just did, because for that we need omega r. For omega r, if you remember the expression, omega r is equal to 1 over 2 pi root LC. So neither we know L, neither we know C, neither we know R, right? So if I try to modify the expression, it should be equal to omega r. Let's take this L to the numerator. So omega r into L by R, right? Now dear students, XL at resonance can be written as omega r into L, right? So it should be equal to XL over R, right? And let me multiply by current RMS over here and RMS over here. So quality factor, it should be equal to this term, it becomes VL, and this terms it becomes VR. So Q, it is coming out to be equal to VL by VR. That's the expression for you, VL by VR. Now VL, so quality factor we just concluded, it is equal to VL by VR. Now how to find VL? How to find VL? How to find VL, sir? Okay. So for the condition of resonance, VL, it is equal to VC, right? So quality factor VL, it should be equal to 200, and what should be the value of VR? This 50 volt. So 200 by 50, its value is coming out to be equal to 4, right? So the correct answer to this problem should be option 2, that is 4. So dear students, that's how you deal with such numericals of quality factor. This was a bit, I'll say, difficult numerical. So you should be thorough, or you should be thorough with the concept of quality factor. You should remember these expressions. I'll highlight for it for you. Omega r by 2 delta omega is r by L. And using this, we modified the expression into this. So you can either remember this formula. You should be thorough with the graph also, right? And you're good to go with the such problems. But this is a bit difficult problem as far as the actual NEET examination is considered, right? But you should be prepared for all kind of problems. Now dear students, it was problem 24 of the original paper, and the correct answer to this problem is option 2. Let's move forward to the next problem. There you go. It is a problem based on the chapter of current electricity, right? And it says that drift velocity of electron is 25 into 10 raised to the power minus 6 meter per second in the electric field of 5 volt per meter then the mobility of electrons will be. So you need to find the mobility of the electrons, and the units are given to you, right? Dear students, what is the expression for the mobility? Mobility is defined as mu, and if anyone knows the formula for the mobility, you can put the answer in the comment box. What is the expression for mobility in the terms of drift velocity and the electric field? So drift velocity is Vd and electric field is E, right? Its unit will be meter per second and its unit will be equal to volt per meter. Okay, no one knows the expression. Mu, it is equal to Vd over E. Mu is equal to Vd over E. Vd is your drift velocity. E is your electric field. What is mu? Obviously, it is drift velocity. Oh, sorry, mobility. Now, if you know the formula, you can put the answer in the comment box if you are able to calculate. I'll calculate it for you. So, mu, it is equal to drift velocity by electric field. The drift velocity is 25 into 10 raised to the power minus 6 upon the value of electric field is 5. So mu is coming out to be equal to 5 into 10 raised to the power minus 6, and the units are meter square, volt inverse, second inverse. Okay, someone is commenting the answer as 2. Yes, 2 should be the correct answer to this problem. Option 1, 3 and 4 are perfectly wrong, right? Yes, 2 is the correct answer to this problem. It is a very simple problem. You just need to remember the expression for the mobility, which is defined as the ratio of drift velocity to the electric field. Vd by E is the formula for the mobility. Simple problem from the chapter of current electricity. Now let's move forward to the next problem. There you go. And this is the problem again on the chapter of thermodynamics. It says that an ideal gas is carried through a thermodynamic process. So ideal gas is carried through a thermodynamic process as shown in the pressure volume diagram. So this is the pressure volume diagram. You need to pick the correct option. Symbols have their usual meaning. Okay. So P is pressure, V is volume, and this is the graph that is given to you. From this graph, I can conclude that pressure is directly proportional to volume, right? Pressure is directly proportional to volume, which means that as the pressure reduces, so is the volume also reducing. Both the pressure and the volume is reducing, so you need to comment. Let us see what do we need to pick. So we need to comment about the change in the temperature, the heat interaction, the internal energy, change in internal energy, and the work interaction. Not to worry about the magnitude part, we just need to comment whether they would be 0 or less than 0 or greater than 0. Okay. And the graph is given to you like this. So PV, it is going from A to B, and the volume is decreasing. Dear students, let's go through the simple concepts. We know that if volume is decreasing, over here you can see that from A to B. So if I try to mark A and B, so over here from A to B, the volume of the system is decreasing. It means that work is being done on the system, and in any case that work done will be negative, right? So you can use this as a thumb rule that since volume is decreasing, that means that the work done should be negative, which means that the first point of conclusion is that work done is less than 0. Work done negative hoga, right? That is the first part of conclusion. What else? To comment about the internal energy, you need to find out the what is happening with the temperature, right? And I have one relation between pressure and volume, that is pressure is directly proportional to volume, but I need one more relation to relate the temperature, either with the pressure or either with the volume, right? So I have P to be equal to kV. I have removed the proportionality and I have put a constant of proportionality, that is K. And I have also got ideal gas equation, PV is equal to nRT, right? So let us do the modification. I'll put P as kV, so it becomes kV square to be equal to nRT. kV square as nRT. So in this case, V square is proportional to T. V square, that is volume of square, is proportional to temperature. Now we very well know that volume is decreasing, which means that the temperature is also going to decrease, right? So temperature is also decreasing. So one of the option, it was saying that delta T is equal to 0. It should be wrong. And since temperature is decreasing, it means that the change in the internal energy, delta U, it should be less than 0. Delta U should be less than 0, right? So first one says that delta T equal to 0. This one is wrong. Delta T is less than 0. Delta Q is equal to 0. See, if we say from the first law of thermodynamics, delta Q, it is equal to delta U plus delta W. Work interaction of the system is negative. Change in internal energy of the system is also negative. So delta U, delta Q, it cannot be 0. It should also be negative, which means that this one is also wrong. Delta U is less than 0. This one seems to be correct. Let's talk about the fourth one. It says that W is greater than 0. Obviously, W is less than 0. So this one seems wrong. So the correct answer to this problem is option 3. Okay, children, students are commenting the answer is option 1. No, not option 1 is not the correct answer. It would have been the correct answer had the graph been like this. This is V and this is P, and the graph is like this. Now, anyone can tell me this graph is valid for which process? What is the name of the process that is in accordance with this graph, PV graph that we just draw? Okay, if no one knows, I'll write the process name over here. Isothermal process. This is the graph for the isothermal process. Isothermal process means temperature should remain constant. Process equation is PV to be equal to constant. Right? So delta T equal to 0, it should be valid for the isothermal process, not the isobaric process. So option 1 is a perfectly wrong statement. It cannot be the right answer to this problem. Right? Now let's move forward to the next problem. And if you understood this problem, let me modify this problem for you. Okay. You have your P, you have your V, and this time it is going like this, and it is like this. This is point A and this is point B. Now you can tell me what should be delta T, what should be delta Q, sign, what should be delta W. I'm only talking about the sign, not the magnitude part. Delta T, delta Q, delta W for the process A to B that is shown to you on the screen. Okay, no, okay. For this process, again, you can draw a conclusion that pressure is directly proportional to volume. But this time, you can see from the graph that the volume is increasing, which means that the work done should be greater than 0. Now, P is proportional to V, right? P is proportional to V. So I can again write that P is equal to kV. Also, PV is equal to nRT. So again, from here I can conclude that V square is proportional to temperature. So if the volume is increasing, it means that the temperature is also increasing, which means that, yes, delta T is greater than 0. And what about delta Q? Can anyone comment about the delta Q, the heat interaction? Okay. Use the first law of thermodynamics. It says that delta Q, it is equal to delta U plus delta W. Delta Q, it is equal to delta U plus delta W. Now, delta W is greater than 0. If delta T is greater than 0, it means that delta U is also greater than 0. So if delta U is greater than 0, delta W is greater than 0, then what should be the value of delta Q? It should be less than 0 or greater than 0. Anyone can put the answer in the comment box. Delta Q, whether it is less than 0 or greater than 0. Okay. I'm waiting for your answers. Anyone, they can put the answer in the comment box if you know what should be the value of delta Q. I've just modified the problem, greater than 0. Okay. So delta U is greater than 0, delta W is greater than 0. It means that from both these and using the first law of thermodynamics, delta Q, it is equal to delta U plus delta W. I can write that delta Q should be greater than 0. Yes, delta Q is greater than 0, right? Yes. So, dear students, I hope you understood the problems and the concept involved with the problems. And with this, I'll end my session. And please keep tuned for more such sessions on different subjects of physics, chemistry, botany, and zoology. And I hope I made all the doubts clear and you are good to go with all these concepts that were discussed in the class. Thank you for watching this video.